Welcome to the chemistry class, my dear students. Let us start studying about the chapter or revising about the chapter solid state. Let us move forward and study the solid state. Solids have a definite mass, volume, and shape. Solids have intermolecular distances very small. Solids have very strong intermolecular forces. The constituents of solid particles have fixed position and they can only oscillate about their mean position. They cannot leave their mean position, but they just can oscillate around their mean position. They are almost incompressible and rigid. These solids are almost incompressible and rigid. Solid can be classified as crystalline solids as well as amorphous solids. On the basis of the nature of order of arrangement of in them, the solids can be classified in two class: amorphous solids and crystalline solids, my dear students. Now let us study. A crystalline solid is a solid in which the arrangement of constituent particle is arranged in the perfect order in a long range, and the same kind of arrangement called unit cell. Unit cell is repeated throughout the crystal. Like sodium chloride, quartz are the example of our crystalline solid. An amorphous solid is any solid that is not a crystalline solid. An amorphous solid is not a solid that is crystalline solid. An amorphous solid is a solid in which the constituent particles are not arranged perfectly, or the arrangement of constituent particles is not repeated throughout the crystal. If the arrangement of constituent particle is found repeating, the repetition is of short range. Please remember that there are some amorphous solids where the arrangement is in order, but this order arrangement is repeated for a short range only. It is not for a long range, and it is not found throughout the crystals. So throughout the crystal, the arrangement is not same and not of the long range. The examples are quartz glass, rubber, glass of different type are the examples of our amorphous solids. Crystalline solids have sharp melting point. On the other hand, amorphous solids do not have sharp melting points, but they gradually soften over a range of temperature. So they do not have sharp melting point and they gradually soften. When you heat them, they become soft, 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 and suddenly they melt and they start falling like a liquid. That is what you can observe into the plastic. But at the same time, the complete plastic will not be turned into liquid. Some part of plastic will be turned into liquid. So they do not have sharp melting point. That is what we can easily understand. Definite characteristics, geometric shape. So crystalline solids have definite characteristics and geometric shape, while the amorphous solids do not have regular shape. Now we should understand about cleavage property. Now first of all, we should understand what is cleavage property. Cleavage property is the property or is an observation when we see a solid to be cut with a sharp edge tool or with a knife. So when cut with a sharp edge tool, they split into two pieces and the newly generated surface is plain and smooth. When cut with the sharp edge tools, amorphous solids cut into two pieces with irregular surface. So please remember, this is what we can understand about the cleavage property of the amorphous solids and crystalline solids. We have seen that the crystalline solid will not have the smooth surface, but the amorphous solids will have the irregular surface. That is what it is being seen. Crystalline solids have a definite characteristics, heat of fusion. So please remember that the heat of fusion for a crystalline solid is fixed and it is definite, and it is generally high also, while amorphous solids do not have definite heat of fusion. So their heat of fusion is not fixed. Crystalline solids are anisotropic in nature, while the amorphous solids are isotropic in nature. We will understand separately what is isotropy and anisotropy. Crystalline solids are called true solids, while the amorphous solids are called pseudo solids. So crystalline solids are considered to be true solids, whereas the amorphous solids are considered to be pseudo solids, or they are super cooled liquids. For example, glass. In crystalline solids, the order of arrangement of constituent particles is of long range, while in amorphous solids, the order of arrangement of constituent particle is of short range. So please remember that the arrangement of order of the constituent particle is short range if it is arranged in order in case of the amorphous solids. Amorphous solids are useful materials like glass, rubbers and plastics. Find their applications in our daily life. Amorphous silicon is one of the best photovoltaic material available for the conversion of sunlight into the electricity. So please remember that there is an amorphous solid which is known as the amorphous silicon, and this amorphous silicon is used to convert the sunlight into the electricity by the cell which is known as the photovoltaic cell or solar cell. Now let us understand, my dear students, about anisotropy and isotropy. What is anisotropy and isotropy? So when same chemical properties such as electrical resistance and refractive index, please remember these two examples, electrical resistance and refractive index of crystalline substances measured along the different directions, the value of such characteristics are different in different direction. This phenomena is called anisotropy. Let us try to understand why the anisotropy happens. In a crystalline solid, the constituent particles are arranged in some order throughout the crystals, same order throughout the crystal, but from different angle, the arrangement may vary. Vary means it is different in a different way. That is what it is vary. It is not VERY, but it is VARY. Please note, my dear students. So you can see here, we have a crystalline solid here. In this crystalline solid, you can see that two type of particles are arranged. One type of particle is represented with the red color dots, whereas the another particle is represented with the blue color circles. So you can see that all the red dots are arranged in an order manner. All the blue dots are arranged in the order manner. So if you go along the x-axis, as you can see here, my dear students, if you go along the x-axis, this is your x-axis, you can see the arrangement that either the blue circles are available, or along the x-axis, either the red circles are available. Same way, if you go along the y-axis, my dear students, you will find that in your path only red particle comes or only blue particle comes. But if you go along the z-axis, my dear students, please look, this is your x-axis, this is your y-axis. But if you go along the z-axis in this manner, now I'll show you one more example. You can see here, I'm going parallelly to it. See here, this is again the z-axis. When you go z-axis, what happens? In your path, you have red dot, blue circle, red dot, blue circle, red dot, blue circle. So the properties like electric conductance or refractive index will be same at x-axis, will be same at y-axis, but will be different at z-axis. So when it comes to the z-axis, this refractive index or electric resistance will be different as compared to the x-axis and y-axis. This is what it happens because when the electricity pass through to provide in the z direction to provide resistance, the different type of arrangement of particle is available. And that is how, my dear students, these phenomena of having different characteristics like the refractive index or electric resistance is known as the anisotropy. And this is how our crystalline solids are anisotropic in nature. Let us see what is written. Along x and y axis, the arrangement is same, but along z axis, the arrangement is not same. As x axis and y axis, thus it is called anisotropy. Due to different arrangement, the constituent particles and the physical property is also different, like electrical conductivity or electrical resistance or refractive indexes. And thus in the different directions, the electrical resistance and the refractive index are different, and this property is known as the anisotropic property. Now let us study about the use of amorphous solids. We know that glass, rubber and plastics find many applications in our daily life. Amorphous silicon is one of the best photovoltaic material available for the conversion of sunlight into the electricity. Now, my dear students, let us study about the crystalline solid, and first we will study about the classification of the crystalline solids. So let us revise the classification of the crystalline solids. First we have the non-polar. First we will study about the molecular solids, like we can have the non-polar molecular solids, we can have the polar molecular solids, we can have the hydrogen bonded molecular solids. So the first class of our crystalline solid is molecular solids, and molecular solids can also be again classified into non-polar molecular solids, polar molecular solids and hydrogen bonded molecular solids. Then the next class is ionic solids. Then the next one is metallic solids. And then the next one is covalent solids. So my dear students, we can say that the crystalline solids is classified into four classes. Number one, molecular solids. Number two, ionic solids. Number three, metallic solids. And number four, covalent solids. These molecular solids can be further classified as a non-polar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. So this is how we classify the crystalline solids. Most of the solid substances are crystalline in the nature. For example, all the metals like copper and silver, non-metallic elements like sulfur, phosphorus and iodine, and compounds like NaCl, ZnS, naphthalene, etc. Now, classification of crystalline solids. So crystalline solids can be classified into various classes like molecular solids, ionic solids, metallic solids, and covalent solids or network solids. They are also called giant molecules. Let us roughly take an idea about all these solids. So molecular solids can again classified into non-polar, polar, and hydrogen bonding. The ionic solids, their three-dimensional arrangement is made up of cation and anion. They are hard, they are brittle, they have high melting. They means ionic solid. Ionic solids have high melting point and boiling point, and they are insulator in the solid state, but in the liquid state or in the molten state or in the aqueous state, they are good conductor of electricity. Then, my dear students, we want to study about the metallic solids. This metallic solid can be explained by the electron C model. That means the electrons are, and these electrons are, let me explain you about the electron C model. Electron C model is a kind of model in which you have a C. You can see that this is the C. This C is made up of various electrons. So let me show you once again. In the sea of various electrons, my dear students, you can see this is the sea of electron. These all negative mark I am doing, they are all the electrons. And in these electrons, my dear students, the metal kernels which are positively charged, they can be observed or they can be seen. You can see these metal kernels, they flow in the sea of electron. These metal kernels are generally positively charged and they can be or they are floating into the sea of electron, and that is what it is known as the electron sea model. You can even think of when you go to the sea or when you go to the river, and suppose you can throw some of the ball which are having air in them. The way this ball floats on the water, same way these metal kernels are floating into the sea of electron, and this model for explaining the metallic solids is known as the electron sea model. The electrons available as an electron sea are responsible for the high conductivity of the metallic solids. These metallic solids also show metallic lusters. Some of the metals are colored. For example, silver has got silvery color and our gold is of golden yellow color. These metallic solids are malleable and these metallic solids are ductile. Then, my dear students, we have the next kind of solid which is known as the covalent solids or network solid. They are the giant molecules. These giant molecules we can see here with the example of two different things. This is what it is, your graphite, and this is what it is, your diamond. You can see that in a diamond, a giant molecule, all these black dots represent the carbon. So no other atom is present other than the carbon, and all these carbon make a giant molecule, and that is why they are known as, or they make the network of carbon molecules with sp3 hybridization. Here in graphite, they have the sp2 hybridization and they make the hexagonal structures, and in these hexagons there is gap, and either the electrons are available in this gap or these electrons are utilized to make various double bond between these carbons. So this free electron is responsible for the conduction of electricity into the graphite, and graphite has layers. That is why these layers can sleep over each other, and that is why graphite is used into the pencil, or graphite is used as a lubricant. Same way, my dear students, if you understand, the graphite has these graphites have got higher melting point, and that is why they can be used as a lubricant even at higher temperatures. Now let us study each type of solids one by one, and let us start with the solid which is known as the molecular solid, my dear students. So let us first study about the molecular solid. First type of molecular solid is known as the non-polar solids. They comprise of either atoms or molecules. Atoms like helium, neon, argon, krypton, xenon, radon, which which are actually the noble gases or inert gases. When they are found into the solid state, the type of solid this element form is known as the non-polar solids, or molecules like iodine, Cl2, H2, where both the atoms which are bonded, they are same. As they are same means they have same electronegativity, and due to same electronegativity, the shared bond pair of electron, my dear students, the shared bond pair of electron, the shared bond pair of electron, my dear students, is not attracted by any single. Both the hydrogen have same electronegativity, and that is why the shared bond pair of electron is not attracted by any single atom, but both atoms have same attraction uh, for this electron shared pair, and that is why it is a non-polar solid. Same way, there are some other solids also which are non-polar. These are generally solids at low temperatures. So these solids are found at low temperatures, and they are soft solids, and these type of solids, the attraction are called the or the intermolecular attraction in this type of solid is known as the van der Waals attractions. Now, before we move and understand the next one, please remember that if we have the molecular solids like CCl4, they have even their, or if we have the solids like BeCl2, there also your mu is equal to 0. So they do not have any dipole moment, and those molecules, those all molecules which have their dipole moment is equal to 0, these all such molecules are considered to be the non-polar molecules, and their solids will be non-polar kind of solids. Now, my dear students, we want to study about the polar molecules. These are generally the solids of HCl and SO2. These type of substances which have your mu is greater than 0, or that is what you can say, that they contain some dipole moment, and due to dipole moment they are considered as a polar molecules. These solids are generally liquid or gaseous at room temperature, but they have dipole-dipole kind of interaction among them. So the type of intermolecular interaction is dipole-dipole interaction, and thus we can say that in the polar molecules there are force of attraction is dipole-dipole kind of interaction, or dipole-dipole force. Then we have the third type of molecular solids which are known as the hydrogen bonded molecules. These are the molecules which have hydrogen bond among them. So this hydrogen bond, due to this hydrogen bonding, which is stronger than the dipole-dipole interaction and van der Waals forces, my dear students, this hydrogen bonding is stronger than compared to the van der Waals forces as well as dipole-dipole kind of interaction. And that is why among these three type of solids, my dear students, either the hydrogen bonding solids or non-polar molecular solids or polar molecular solids, the boiling and melting point of hydrogen bonding solid is comparatively higher. And that is how we understand the three various types of the molecular solids. Now, my dear students, we are going to study about the ionic solids. So let's study about the ionic solids. Ionic solids are a kind of solids which are made by proper arrangement of the positive and negative ions, which are called cations and anions. These positive and negative ions are bonded together by the electrostatic force of attraction. So in ionic solids, the force of attraction is electrostatic force of attraction, which is a strong force that gives strength, and melting and boiling points are higher for such compounds or for such solids. Hello, dear students, can you hear me?
Yes, sir.
Okay,
Yes, sir.
so these type of solids are insulators in the solid state, but they are conductor in the uh, molten state or in their aqueous solutions or in their liquid state. That is what we have seen it. Then, my dear students, we have the covalent or network solids. Three other, so in this covalent or network solid, my dear students, actually I have missed one page, so let us go there. Thus, they are water soluble, means ionic solids are water soluble, and conductivity of ionic solids in the molten state of aqueous state is due to the free ions. So, my dear students, we have seen that ionic solids are made up of ions. These ions generally ionizes or dissociate into the water and thus into their aqueous solution, or in their molten state or liquid state there are free ions available, and these free ions are responsible for their electrical conductivity. So these free ions helps to conduct the electricity or help the passage of electricity. Then, my dear students, we have metallic solid to study about. These are the solids that have metal ions and free electrons. These metal ions, sometimes also called metal kernels. Metal ions are also called kernels, and these metal ions float in the sea of free electrons. These metal ions generally floats into the sea of electrons. This makes the electron C model of the metallic solids, which I have explained you. The electron C model explain a greater conductivity of heat and electricity due to the free electrons which are which are surrounded by the metal kernels. So these free electrons are responsible for the greater conductivity of these metallic solids. It can also explain the color of the metals by exciting the electrons which are free of metal, and metallic luster can also be understood. Metals are sonorous and so on. That is what you have studied into the previous standards about their characteristics in detail. Now, my dear students, we have the next one to study about, which are known as the covalent solids. These covalent solids are, these type of solids are generally uh, made or formed by the covalent bond between the atoms. Carbon has got graphite and diamond are the example of covalent network solids. The nature of solids called graphite, it's soft and and is used as a lubricant at high temperature due to its structure in which the layers of carbon slides over each other. Each carbon is bonded with, let us study the structure of graphite. In graphite, my dear students, if we look at the structure of graphite, we see that each carbon is bonded with three other carbon that make a hexagonal network of CC bond, and the bond length is 141.5 picometer, my dear students. And this distance between the two layers is 340 picometer. The bond length is 141.5 picometer. All the carbons are sp2 hybridized, and graphite can be used as an inert electrode because the electrons either available between the layers, or these electrons which are used to make some of the double bond of these carbons, they allow it to conduct electricity, and that is why this graphite are good conductor of electricity, and that is why graphite is used as an inert electrode, my dear students, which do not take part into the chemical reactions, but it can be used to pass the electricity. Graphite is a good conductor of electricity, or it is used as an electrode. In case of diamond, the carbon atom is bonded with four other carbon atom in a tetrahedral manner, and that is mainly make the carbon the most strong substance that exists on the earth. So diamond, or the allotrope of carbon, which is diamond, is the most strongest substance on the earth that exists. It is non-conductor of heat and electricity. Actually, the diamond conduct heat but not conduct electricity. So please remember that diamond conduct heat, but it does not conduct electricity. Please remember diamond, it is a mistake here. Diamond is a good conductor of heat, but it is not good conductor of electricity. At the same time, it has very high melting point as well as very high boiling point. Diamond can be used as an abrasive to cut the hard substances. So my dear students, please understand the meaning of abrasive. Abrasive are the substances which are used into the cutting tools to cut the other substances. For example, diamond can be cut only by diamond, or diamond is polished by only diamonds, and that is why, but diamond is so hard that it can cut the other substances very well, and that is why diamond is used as an abrasive, and this diamond is used into the cutting tools. In one more example I would like to give you, my dear students, that is what it is known as the corundum, which is your silica SiO2. It is also a giant network solid, and that also is used for cutting the other substances. It is also known as the corundum or silica. In graphite, carbon atom is bonded with three other carbon atom in the same layer, and the fourth valence electron is present between the different layers, and and it is free to move about. These free electrons make graphite a good conductor of electricity, my dear students. Then, my dear students, we want to study about the crystalline solids and unit cells. That we will study into the next chapters, or sorry, into the next lecture. Now, if you have any doubt, you can ask me, or you can move to the next class.